decided I didn't want to bother you with it. Hang on, let's flip. Come on, can I flip? Alright, I'll just put a light on. I decided I didn't want to bother you with an hour and a half of waiting for this thing to get up to speed. And because it is a long time to wait. So I've had this running for about, I don't know, 14 minutes so far. My input current at the moment is about where it was yesterday. It's a bit too high really. Now I put the new segments in. So there's my old segments I took out, which are technically ferrite. There's 3 of them actually. So I took the ferrites out of these 3, put them in the new segments, which were actually on there, which are now in the rotor. I rebalanced the rotor, and I noticed straight away there was actually more cogging, which is not good because I was trying to get rid of the cogging. So anyway, I've been waiting for quite a while because yesterday, if you remember, my peaks were about 14 RPM were about 1466 at the minimum, and then it actually climbed to 1550, and that was the max peak, and that was yesterday, the 7th of April. My peak voltage was 2.53 volts AC without any load, and my maximum loaded current was about 33 milliamps. I didn't actually write down how many RPMs we lost, but there's no problem, you can just watch the video and work that out. So it's, instead of us having to wait an hour and a half or whatever we did yesterday, which was a long wait, I thought, well, I'm just going to let this thing climb up to speed and then we'll see what we got. So the peak, actually, we seem to have lost 100 RPM. Oh, probably more than that because of the nanocrystalline material. So we're basically peaking at about 1420, around 1420, 22. Actually, it's more than that. So we're getting to about 1426 RPM roughly. It's fluctuating a little bit, but interestingly, my voltage is a lot better on the AC side. So my voltage is actually got to about 2 volts when I was only at 1200 RPM. So we're actually 2.66 volts now AC, which is actually better. So we're getting a better voltage even with less RPM, because obviously the coupling is there's more coupling there. So I haven't actually got the oscilloscope hooked up right now, but I suppose I might, to make it a little bit more interesting, I suppose I could clip my leads on and let you all look at that, if I can get these things clipped on without pulling everything apart. I'll better turn it on first, get it warmed up. Right, let that thing warm up a minute. I'm going to clip these on here. If I can do it without knocking the other leads off, that's the trick, is to get this on without knocking the other leads off, because this soldered, there's a bit of solder on there and it's kind of bulky, hard to clip onto. Right, so there's the waveform. Remember to divide the voltage by 10 because we're using a times 10 scale on the oscilloscope, but the probe is actually set to times 1. Now, because the segments are not matched, I mean, because I've got 3 segments of one configuration, 3 segments of the other configuration, we have a lot of glitching, a lot of twitching going on with the waveform. Well, that's to be expected until I get another 3 segments made exactly the same as the other 3. So there's 2 different sets of segments in there, which is causing this weird waveform discrepancy. Right, that's another reason why I wanted to show you the waveform anyway, because we have, this is what happens if you have different segment arrangements. Now obviously the peak to peak is that you move the decimal point 1 place to the left, so it's actually peak to peak is actually 8.4 volts roughly. It's jumping around a bit. And the cyclic RMS is 2.76, not 27.6, it's actually 2.76. So we've got a good cyclic RMS now, actually. It's better than before. You could almost run something with that, probably run an LED. So that's the waveform. And our peak hour RPM is at 1440. I wish it would climb up more. Oh, it's actually going up even more. Good. I want it to go up more, because what I might do actually, this live stream on the phone, I can stop it and leave it open so I can resume it. So that's what I'll probably do, because it saves a lot of time, so we don't get bored waiting. So what I'll probably do is, in a minute or two, I'm just going to leave this thing running for probably another 30 minutes or so. I'm worried about the motor getting too warm though, that's the only thing. I'll probably leave it running another 30 minutes and see if we actually get any more speed out of it, because I can close out this live stream any time later on today. So then I can just resume it and give you an update after about 30 minutes, because and that's the AC. It's still climbing. Oh, it just went up to 2.67, then it dropped back again. There we go, 2.67. So it's still climbing a bit. As long as I'm seeing it climbing, I need to keep obviously recording it. Oh yeah, the current. Now the current, we're still seeing a drop in current when I put the load on. So let's just flick it to current for a minute. We actually do a better current now though. Current is, it is slowing down a bit though. Probably hear it. RPM. Obviously the waveform's collapsed because it's under current. So we're losing about, probably, what is it, probably 70 or 80 RPM or something. Going back up again. Good. I don't want to lose too much. Now our peak current seems to be 34.7. It's going up again. Oh, it's weird shit going on here. 35 milliamps. Probably 35 milliamps near enough. It's twitching around a bit. So to be honest with you, that nanocrystalline appears to have more cogging, more drag than the ferrites do, which I'm kind of sad about. I was hoping it would be better, but it seems to have more drag on it. The only other thing I could possibly try is to find some ferrite, or cut some ferrite even, to create my my S bend thing that goes on my segments. You saw it in the previous live stream. What I think I should do is put a link to the previous live stream in the description of this live stream, and when I finish this live stream, put a link to the previous live stream in this live stream, so that people can just click and look at the comparisons between both the live streams. I'll try and do that. I'm very forgetful though. I'll try and do it. I'll do my best. So yeah, we're actually doing a lot better, because our peak current yesterday was 33 milliamps. That's what I wrote down. Max loading was 33 milliamps. So we're actually doing 34 point, well, near enough 35, 34.4. It's jumping around a bit. 34 and a half. It's near enough 35. But 34 and a half, I'd call it. But our RPM is no longer dropping anyway. It's twitching around. It's because it's Sunday, everybody's at home cooking and whatever, doing the tea. It's about 6:30 at the moment, so it's tea time. Yeah, look at the clock. It's 20 minutes past, it's hard to see that clock, I know. It's 22 minutes past 6 right now, so everyone's doing the tea, so the voltage is the mains. It's affecting my voltage on here, on my power supply, which is driving the motor, which is causing it to twitch. I don't know if you can see the needle twitch, but it does. It tends to... Oh, stop shaking, my arm's shaking. I don't know if you can see it move around, it just twitch a bit. I've noticed it twitching on there sometimes. It's hard to see it. Yeah. Anyway, I'm going to leave it on voltage because I want to see how much, see if it'll climb anymore. I'm hoping it'll go up to closer to 1550, but I don't think I'm going to get there. Not without changing settings. I'm not going to do that because it will be invalid. The test will be totally invalid if I did that. So, yeah, current 34.5 milliamps, which is not bad. So let's go back to voltage. Oh, I'm on 2 watt range. It's over limit. Right, so yeah, I'll pick up that little bit of speed now. Yeah, obviously it's a bit of a fail as regards the nanocrystalline because I was hoping it would circumvent some of the drag, but it seems to have actually created more drag. So as I say, I'll leave the live stream open, so anyone watching this is going to say, oh, where's the live stream gone? It says it's live, but it's not, it's just stopped, it's frozen. No, it's not frozen. I'm just going to stop it and leave it open, and I'm going to come back in about half an hour to an hour and conclude and see if we've had any improvements. Oh, we went up to 2.7 volts AC just there. Look at that. 2.7 volts AC. Yeah, well, so I'm hoping it'll go up to 3 volts. I really am. If this thing will climb up to 3 volts, I'll be really, really chuffed because that's a winner. I mean, especially at 1,440 RPM. I mean, that's almost double what we were getting previously. Double voltage, I mean. Yeah, we're still going up. So, yeah, the waveform say it won't be right until I get the other 3 segments done. But I can't print the other 3 segments because my filaments nearly run out. You can see the black. You can see the black gaps. That's the spool underneath. So I don't think there's enough filament. There's definitely not enough filament to do another 3 segments. So I'm going to have to get some more of that next week. Oh, is it next? Yeah, next week. So yeah, the waveform's a bit uneven. It will be until I get the other 3 done. Yeah. Alright, I'll leave this live stream open and I'll try and resume it a bit later on. Okay, I'll see you later. Alright, so I'm resuming the stream. Right, so I waited about half an hour. I didn't wait very long because it's not moving up. It's still around the same 2.68, 2.7 volts AC. It's 2.7. It's just dropped a bit, then went back up again, and then back, yeah, it's up and down. So it's not actually climbing any more than 2.7. So yeah, I guess that concludes this this test. So I'm going to finalize this live stream and now it won't show me 2.7. It was just there a minute ago. And I'll come back. Oh, there it is. I see. It's playing games with me. And our max RPM is 1444. So yeah. Anyway, I turn my scope off. There's no point in watching that. So yeah, interesting results. Based on that, I would say we basically lost about 100 and, well, looking at my settings yesterday, we had 1550 max. We had a 1466 earlier reading on the RPM. We're not far off that, to be honest. But we did peak at 1550. But bear in mind that this could all be due to the fact that the electrical supply is fluctuating at the moment, and there might be a heavier load because it is Sunday evening. So a lot of people will be cooking Sunday dinner, and obviously the mains might be down. So it could be that the mains voltage is a bit lower than what it was when they did the test yesterday, because Saturdays people tend to go out more. So yeah, I'll probably do another test just to verify this without changing anything. Maybe tomorrow or Monday, when it's probably the electrical supply is a bit more stable, and see if we actually do peak at 1550, because I really want it to do that, or go even higher than that. And I can't change anything. I can't change my power supply. I can't change anything that would invalidate the test. And if you notice, I actually numbered all these 1, 2, 3, so that when I disassembled it, I put it all back exactly the same way. And that stepped right on that corner lip there. I actually drew a black line on there as well, which I drew a black line so I could get it all exactly back together the way it was without changing anything. So I got it as close as possible. I don't really need this thing on here. It's just a paperweight, but I put it on there simply because when it slows down, it has a little tendency to wobble a little bit, and I just didn't want it to move on the table because of the RPM meter, because the RPM sensor is right next to the rotor there, look, and if it moves it could catch on there. Oh, it's pretty close as well, look. Very close there, look. So I didn't want it to move, so anyway, I'm going to turn the power off now, so it'll just run down on the supercapacitors. I'll put it on current actually. I'm on current. And we'll see how quick it slows down on current. We can time it, probably compare it to yesterday's. You know, when we did it on voltage. See if it slows down more quickly. Might do, because there is a bit of cogging on it. A bit more cogging than I wanted. Don't know if I can get the RPM meter in. Where is it? I can't see it. Oh, it's up there. Probably can't see it very well right across the room. But we're at 1030 RPM, 1023, 1016, 1009, 1001, 993, 986, 978, 970, 961, 952, 944, 937, 931, 923. Seem to be slowing down more quickly. Under load. Yeah, so I've got to work out this this segment arrangement. I've got to figure it out because I want less drag, not more. But I like the output being higher. Surprisingly, we're still at 22 milliamps right now. Even though we're right down at 818 RPM right now, so. Uh, 783, 776, 768 RPM. This is 760, 752. No, there's no point in calling it out anyway. I'll just wait until it stops. Current output is still 19 milliamps. It was, then it dropped. RPM 479. Just dropped to 472. 463. Yeah, I normally disconnect the supercapacitors at this point to save a bit of juice in them to make it easy to start when I'm starting with flat supercapacitors. So I'm going to disconnect it now. Oops, disconnected it completely, damn it. I just went to disconnect one end. You'll see about the cogging in a minute. Yeah, it's a bit tight. Okay, turn my meter off. Leave it on volts. Wrong one. Oh shit. Right. Okay, so yeah, there's good and bad. The output voltage obviously is good, but and the current output is good, but the fact that I've lost a bit of RPM is bad because I don't want to be losing RPM. The objective is to create more gain on the RPM and also create more gain on the output at the same time. And if one subtracts from the other, then it's not a good gain, is it? Anyway, that's it for now. Thank you for watching.